Why does Ethereum need Layer 2? Ethereum originally handled everything on a single layer. As Ethereum grew and usage increased, fees became more expensive and throughput remained constrained. It ran into a structural problem shared by every blockchain. It's called the blockchain trilemma. A network can optimize for only two of three properties at once: decentralization, security, and scalability. Improving one puts pressure on the others. Ethereum made a deliberate choice: security and decentralization over scalability. Scalability had to be solved differently. The answer was a second layer, one designed specifically for execution volume, anchored to Ethereum for final settlement. Execution could happen elsewhere. Ethereum would verify and settle the result. Let's see how each layer works, from transaction to settlement. On Ethereum Layer 1, the full transaction pipeline happens directly on the base layer. On Layer 1, verification is built into execution. On Layer 2, verification happens later on Layer 1. Instead of executing every transaction directly, Layer 1 receives the batch from Layer 2 and checks whether it is valid. Both layers end in the same place: settlement on Layer 1. The difference is how much work reaches Layer 1 directly and how much is handled before it gets there. So what actually happens to those transactions before they reach Layer 1? Instead of publishing every transaction individually to Layer 1, Rollups group many transactions together into batches. A transaction originates on the Layer 2 network. A sequencer, software that collects and orders incoming transactions, processes it alongside many others. Once enough transactions have accumulated, the sequencer packs them into a batch. Think of it as a shipping container. Instead of sending every package to Ethereum separately, thousands of transactions are compressed and shipped together as one. The cost of that single delivery is shared across every transaction inside. That container arrives at the bridge contract, a smart contract deployed on Ethereum Layer 1. The bridge contract enforces the rules of the rollup. It checks whether the batch is valid before the state is accepted on Ethereum. But how does Ethereum actually know if a batch is valid? It depends on the type of rollup. Two main verification models exist. In an optimistic rollup, the batch is accepted first. A challenge period follows before finalization. Arbitrum, Optimism, and Base use this model. In a ZK rollup, a proof is verified before the batch is finalized. ZK Sync, Starknet, and Scroll use this approach. Two models, one outcome. Transactions executed on Layer 2, settled on Ethereum. So what does that mean for users? For users, the shift to Layer 2 brings measurable differences. First, faster transactions. Most Layer 2 transactions are confirmed much faster than on Ethereum mainnet. Second, lower fees. Transaction fees are often 10 to 100 times lower than on Ethereum mainnet. Third, familiar interface. Same wallets, same assets. The same Ethereum wallet works across most Layer 2 networks. The architecture continues to evolve. Layer 3 networks are beginning to appear, built on top of existing Layer 2 rollups. They target specific use cases: high-volume gaming environments, privacy-focused applications, or chains that need custom execution rules. The same principle applies: execution at one level, settlement at the layer below. Ethereum didn't try to do everything at once. It chose a foundation and let the rest be built on top. Layer 1 settles, Layer 2 executes, Layer 3 specializes. Each layer anchored to the one below it. That's not complexity, that's intentional separation of concerns. And that separation is what allows Ethereum to scale.